In this video, we're going to look at the idea of expressions. So let's recall the candle burning context, where a 14-inch candle is lit and steadily burns until it is burned out. In the previous video, we defined the variable B to represent the burned length of the candle in inches. And as the candle burns, the value of B varies. So as the candle burns, B is increasing. If we imagine pausing the situation, you should notice that the remaining length of the candle in inches is the difference between 14 and B. Or the remaining length of the candle in inches is B inches less than 14. And therefore, if we knew the value of B, we could compute 14 minus B, and that would tell us the remaining length of the candle. Therefore, we can reconceptualize the situation as in this animation, where we have the variable B representing the burned length of the candle in inches, and then 14 minus B always tells us the remaining length of the candle in inches. And therefore, we say 14 minus B is an expression in terms of B that represents the remaining length of the candle in inches. Now, we say this expression is in terms of B because we're using the variable B to represent the value of this new quantity. So we can formalize this idea. In general, an expression consists of numbers, variables, and operators grouped together to represent the value of a quantity. So basically, we take variables and numbers and operators from other quantities and use them to create expressions that represent the values of new quantities. So for example, each of the following expressions is written in terms of x since their value depends on the value of x. So x plus 17, or 3 minus x cubed, or x squared plus 4x, those are all expressions in terms of x that might represent the value of a new quantity. Let's look at one last example. Suppose John is always twice as tall as Harry, and we'll let the variable x represent Harry's height in feet. So John's height is 2 times as large as Harry's height, and therefore, if Harry's height in feet is represented by x, then if we find a value that's 2 times as large as that, so 2x, that should tell us John's height in feet. And therefore, 2x is an expression in terms of x that represents John's height in feet. And again, we call this a variable expression in terms of x. It's in terms of x because we used the value of x to represent the value of this new quantity. It's a variable expression because we're imagining the variable x varying.